Well, hello, everyone. I want to welcome you to the Requirement Working Group monthly meeting. We are alternating between our Exchange Cafe and our presentation each month. And this month is a presentation. Before we get into introducing the speaker, I wanted to let everyone know that all of our products we've been working on and updating are now in the Nkosi store. They finished getting all that done yesterday. And so all the members can go to the store and they can download these documents from the store. For those in the Requirement Working Group and Nkosi members, you can also go to the Connect site and go to Requirements Working Group. And these products are all available there as well. So we put a lot of time and effort in this over the last several years. And so we're really proud of the fact that we have these products in there. The Needs and Requirements Manual, the first version of that was called the Needs, Requirements, Verification, Validation Lifecycle Manual, and it was put in the store just before IW. Some people said the title was too long, so we shortened the main title and then included a subtitle with the similar information in it. So this is version 1.1, and there's some minor changes in it to make sure all of our products are in alignment with each other. So you see that they all refer to each other back and forth, all 5 of these. If you haven't got a copy, I encourage you to get a copy of these products and spread the word. So we got a lot of participants today. Let me introduce our topic, our presenter. The title is Demonstrating System Engineering Value Using Traceability Measurement. Jama Software has done a lot of work in this area concerning traceability. And so I've had several people ask to learn more about this. And so Cary, their solutions lead director, has graciously volunteered to give us that presentation. You can read what's on here, where she has lots of experience in system engineering from a practical hands-on perspective, as well as focusing on the system engineering use of Jama Connect to help better manage our products across the lifecycle. With that, let Cary take over.
Thank you for the introduction. I definitely don't want to take credit for this entire presentation because I'm joined by a couple of colleagues that are really terrific and have done a lot of work. So I think to kind of kick this off, I want to kind of set the foundation for what we're going to present today, sort of the building blocks of what traceability is. And we're going to be measuring that and showing value of traceability by kind of starting with, what is a traceability model? How do you define that? What does that look like? We'll talk about the benefits of a model used to construct traceability. We'll go through our benchmark study. We'll talk about sort of the correlations that we see between traceability and project success. We have some examples of how traceability can lead to success as well. And we'll talk about the Traceability Alliance. So what do we mean by a traceability model? Essentially, when you're using Jama software, really any software, defining a traceability model are sort of those building blocks. And the first thing that we do inside of Jama Connect is just define the necessary object types. So if you might have something that looks like you start with needs, and then you have another object type for system requirement, another object type for subsystem requirement. And you might also then throw in other elements within the life cycle for validations, different kinds of verifications, behaviors or risks. Architecture types, different types of architecture, or maybe you even throw in user stories. And these represent the building blocks that you're going to start measuring your traceability with. And then to finish this trace data model is we find which object types are allowed to be related to each other. So I'm allowed to create traces between a need and a system requirement and a system requirement and a subsystem requirement. And these names, these aren't necessarily in stone as system requirement and subsystem requirement. Different industries, different types of customers might use hardware requirement or software requirement or instead of subsystem requirement. These can be tuned to be project specific. And so as you create these relationships, this describes the model that when you are then creating requirements or creating needs or creating verifications, this sort of model underlies the formation of the data. And you apply this model to the projects So when you're working on a project, you're making a new antenna that's going to be on a satellite, you would then be constrained by this model to create data and relate data and use only the trace relationships allowed in this model. So having this model enables you to have consistency, but it also enables us to start measuring not only one project, but measuring many projects. And so when we talk about measuring, and Kevin's going to go into the traceability score, but I thought it was important to kind of show you how we come up with expected relationships and established relationships. So when we talk about the traceability score, if you look at look at the system requirement in this diagram, it has a number 5. So it has 5 different types of objects that can be traced to it. In this example is a functional requirement, system requirement, a failure analysis, or high-level requirement or a verification. So those are 5 different types of objects that could have traces. And now, if I had 10 system requirements, then I might have more expected relationships. So that would be taken into account into how the metric is actually measured. And I'd really like to introduce Kevin Pearson now. Now, Kevin Pearson is our Director of Analytics at Jama Software, and he is responsible for leading both our internal and external data initiatives, including this traceability benchmarking, which he is going to jump right into and talk about with you right now.
Thanks, Cary. And good afternoon, everyone. Kevin Pearson. In my section of this presentation, I'm first going to talk about live traceability, what that kind of means to us, as well as really focus in on the measurement component of live traceability, which we did quite a lot of work in requirements benchmark that we released a couple months ago. I'll kind of talk about both the report itself, the conclusions we have from the report, as well as how we're going about sharing it with customers and generally educating the market on it. So first off, just to level set, I figured it would be worth defining live traceability for the group in case anyone isn't quite familiar with the term. And so on the slide, we have our working definition for it, which is the ability for any engineer at any time to see the most up-to-date and complete upstream and downstream information for any requirement, no matter the stage of system development or how many siloed tools and teams it spans. So really, I see this as traditional traceability, but with the explicit assumption that it's usable at all points in the project, not just at the very end for compliance reasons or at the very beginning as kind of more of a theoretical concept. So really, what live traceability looks like in concept is 2 components. One, it's having an established methodology for how your project should be conducted and how the various elements should be related. But where live traceability comes in is that continual feedback loop to make sure that your process, that your methodology is being adhered to. And this is where measurement comes in. With this idea of measurement in mind, we surveyed the industry and really weren't able to find an industry agreed upon metric or method for measuring traceability by. So we leveraged the data set of projects we have in our customer base and essentially both try to determine a metric that could be used to measure traceability and in turn adherence to your process, as well as determine if by using this metric, we could determine any correlations between higher levels of traceability and improved product development outcomes, which I think has always been an assertion in the industry, but as far as we're aware, at least, it has never really been proven out. So in the next couple slides, I'll discuss the metric we created, discuss these correlations, and then discuss some of our ideas as to why traceability matters, because spoiler alert, it does. So I think just to set the stage for measurement, there's a couple things you need in place. So first off, Cary discussed the idea of a model-based way for defining the items and relationships in your project. This is obviously important because you need something to measure by. There's some other difficulties in determining a metric and measurement though, which is I think prevented the industry from measuring traceability before, which is that projects are so unique and vary completely in their size, in their complexity, in the names of items involved, even in their end product, right? So any metric needs to be both consistent to interpret, no matter the use case, complexity, size, right? But it also needs to be able to be calculated in a user's defined data model. It can't rely on us having to plug it into some Jama defined, view of the world. It needs to be customer native. So faced with this task, the metric that we proposed in our benchmark survey is the traceability score. And the idea of the traceability score is to first start by understanding the total number of expected relationships in your project. And so this gets to what Cary said, is that if you have a requirement and it has 5 different edges or, rules defined that it should connect to a user need, should connect to a sub requirement, should connect to a test case. All of those specified nodes are expected relationships. You can then basically sum that up for every single item in your project, and that gives you the total denominator of expected relationships. Then it's simply understanding how many of those relationships have actually been established. So how many requirements have actually been refined to sub-requirements, or how many requirements are actually being verified by test cases. And so the ratio of the established relationships divided by the total number of expected relationships is the traceability score. And one nice element about this definition is that it can be calculated at multiple granularities within the project. So you could calculate the traceability score for a single item. You could calculate the traceability score for a particular subsystem of your project, or as we tend to focus on, you can calculate it for the project as a whole. So we calculated our score across the data set of projects that we have. And really what we did with these scores was first determine the distribution, which was roughly normal, a little bit of a tail towards the lower side. And we then focused on breaking out these projects into quartiles based on their traceability scores, i.e. projects in the top quartile or in the top 25% scores, projects in the bottom quartile or in the bottom 25%. And then really compared these projects in different quartiles to see if there were any interesting correlations between meaningful product development outcomes that we're able to identify in Jama Connect. So we looked at defect volumes, we looked at test failure rates, we looked at rework rates, we looked just at general item creation efficiency, as well as the percentage of requirements that were being verified. And so the end result of this was we did find some interesting correlations between higher traceability and improved product development outcomes. And so specifically, we found some indications of faster time to market, which we identified through faster testing cycle times, as well as faster defect discovery cycle times, or how fast you're kind of finding and remediating your defects once testing begins. And then we also found indications of higher quality, which we determined through both the percentage of requirements that are being verified, as well as test case success rates or test case failure rates. So really our end conclusion from this is it does seem like traceability and the traceability score that we proposed seem to have some merit in tracking. And so really, like the natural question is why? Why does traceability potentially improve product development outcomes? I will say this is outside the data. This is kind of outside the benchmark survey. But really, our idea is that, I don't think this will be too foreign to say, that unknowns and uncertainties in the product development process create risk. At a minimum, if you're uncertain of the scope of the work and uncertain of, if you're complete or not, if there's any problems left, that equals extra time remediating the problems and just trying to get as much confidence as possible. At the worst end, you could miss something. You could miss a requirement. You could, have an unintended failure that you didn't expect, which can be catastrophic. So really, higher level of traceabilities, they limit uncertainty. And you see this in completeness, that you have confirmation that you've met all your requirements, checked all the boxes. You have confirmation of correctness because all of your requirements are being verified and you have an explicit pass or fail on them. You have consistency in how your project's being managed. And this is particularly important if you have disparate or siloed teams working. Everyone is working on the same template and same methodology, which has some natural efficiencies to be gained right there. Scope management, you're certain that all of your requirements and development efforts have a purpose. You're not gold plating, or you don't have requirements that a customer didn't ask for. And then finally, too, if something and when something changes, because that always happens, like you're able to understand the implications of the change and hopefully, understand the impacts and remediate the impacts as fast as possible. And so just to kind of give the group an idea of how we're using this score, we're starting to introduce the score to our customers and basically first helping them gain comfort around the idea of the traceability score itself, but really focusing on tracking the traceability score over time to help customers understand if they're either improving in traceability or regressing over time. And then second off, providing a benchmark too, just to sort of understand, like, compared to other companies in the industry, what is your relative level of maturity? So we just really see this as being an interesting way to sort of measure that and try to prove improvement in projects over time. And so far, I'd say our feedback has been really positive. I think for individual contributors, it seems like a nice feature. And for people that are a little bit more focused on change management, they see measurement as an effective method for sort of understanding their projects and hopefully driving improvement.
Awesome. Okay. I'm going to extend this now and talk a little bit about how live traceability sort of extends across the ecosystem. So we're not just measuring traceability just inside of requirements, but requirements touch a lot of the other tools in the ecosystem. And so what we've done today is we've thought of, yes, we have lots of integrations with many tools out there. And one of the initiatives that we've taken here at Jama is what we call our Traceability Alliance. So our Traceability Alliance, we just announced it a few months back, but essentially it is a way for us as a group of organizations to come together to all agree upon a consistent way to manage the data, to agree to always expose our APIs and our approaches for integrations in a consistent way so that live traceability is not just siloed, but it can span the entire ecosystem. Actually, I'm joined today. I invited LDRA to come and talk to us about what these guys are doing. And Jared Fry from LDRA, I'll let you introduce yourself and talk about how you guys view traceability.
Hi, thank you. My name is Jared Fry. I manage the field application engineering team for LDRA in the US. Fundamentally, we're a software analysis and testing tool. So we run static analysis against developed source code, can do unit testing, and collect structural code coverage. But being able to tie those things back into traceability is when it's usually important for our customers, who many of them are looking for some sort of safety or security type standard. But also it really completes the full picture when you look at that traceability and provides a lot of benefits to any customer who's kind of looking to get that extension. And I think everything that was mentioned on previous slides about the benefits of traceability continues to carry on if you look at connecting a requirement to the actual code that was developed for that requirement, the tests and testing artifacts that are used to verify that that requirement has been met, or even code coverage. So if you run the tests that are mapped to a requirement, you should get coverage on the code that is also mapped to that requirement. If you have holes in your coverage after you've run your tests, well, potentially you have a lack of requirements or the code hasn't been implemented correctly. So it can really kind of highlight deficiencies in many places, the same way that looking at how the traceability across the entire system can affect the application. Then having this live traceability where you can see how things all the way upstream to downstream to the code itself then becomes hugely important in reducing costs and time for customers.
Thanks, Jared. One of the exciting things, and I skipped over this slide because I thought it might be great to sort of just have it as a leave behind, is we offer a traceability diagnostic, and it essentially is an inventory of your traceable data across the ecosystem. So if you're using Jama plus LDRA plus DOORS plus any other tool, we can do that inventory with you, that we can apply sort of a trace relationship rule review. What does it look like? How should all of that data be traced together? We can help you calculate the debt. And then based upon the calculations and the review, we can kind of give you an estimation on maybe some negative product outcomes that you might be facing. And we do this for customers and non-customers for free. So if there's anybody that would like to do that, feel free to take advantage. But I kind of love to answer any questions that you guys have. Use this time as, a collaborative. Give us feedback on what you've heard.
Cary, can you see the chat? Pamela asked a question.
Okay, here's Pamela. Pamela asks, is it a defect when you don't have a system requirement that traces to a user requirement? And perhaps it'll be described later. How do you identify any unused user and system requirements? I'll take a stab first, and then Kevin, you can take a stab. How's that?
Yeah, sounds great.
So when you have a traceability model in place in Jama Connect, you can create filters that say, hey, show me any system requirements that do not have a connection to a verification. And you can make it very fine-grained as well. Show me any system requirements that have a connection to a verification that has a status equal to blah, blah, blah. You can run filters that say, show me system requirements that have no verification. So whether it has something connected to it or not, you can run filterable queries across the data because this trace data model is there for you to reference. Kevin, you want to take this?
First off, to your first question about defects. Defects for us are actual product or software defects that are identified in the testing phase. So, the defects you'd see in Jira or Bugzilla, whatever bug tracker you have. And to the question about unused system requirements, that is something where I think customers, to really operationalize the traceability score, it's really what you need is the ability to drill down and focus on specific relationships that are relevant to your particular development phase or specific subsystems that a particular user would be in charge of. So, as Cary said, I think the idea would be to leverage filters to kind of get a more fine-grained granularity on the traceability score and operationalize it that way. I will say a lot of our customers keep their projects clean and leave out unused requirements for the most part, but definitely we do see some that are in projects, and sometimes that's just a little bit of dirtiness of data we need to deal with.
All right, Lou, you asked a question.
Before that, can I comment on that previous question?
Yeah, please.
For Pamela, the chart that's showing here, what Cary talked about is you established the traceability relationship model in the tool. And so if you have an entity called a user requirement or a user need, and then that is going to be transformed into a system requirement or a design input requirement, whatever name you give it, then you establish that as part of your model. And then I think what you're using the word defect for is if you fail to establish that traceability, then my understanding, correct me, Cary, that Jama will give you a little red indication that that link has not been established.
It does. It would also show up in your traceability score. If you have a requirement, but it's missing something. So if you have a need that's missing a system requirement, it's going to show that as something that's missing. So you will see that, at least in Jama Connect's UI, that it doesn't have something there, but it also shows up in a trace score that it's part of the calculation.
Yeah, and I think that's really where we see the traceability score being useful from the operational standpoint is if you expect 100% coverage between your requirements and test cases and you check it every week, then you're able to see the cases where that doesn't exist and remediate them, as quick as possible.
What I like about the live traceability is once I establish the model, and like in my mind, if I've baselined a set of stakeholder needs, and then I expect all of those to be implemented by requirements, then if I had any needs that didn't trace to a requirement, then that would be a big red flag to me because I haven't implemented that need that I baselined. The stakeholders said they needed that thing and I haven't implemented it in requirements. I have that problem. I like going to another tool, the RWG, so that allows me now to take a design input requirement and then trace that to a code implementation. And so if I have a design input requirement that was baseline and it's not being implemented by code, to me, that's another big red flag. I would want to know, why have you not implemented this requirement? The concept of unused user and system requirements to me doesn't really equate, because if I really baseline those, if I establish this model, I would expect there not to be any unused, or if there is, that in itself is a defect, because now this program is going to fail system verification, because system verification is just, did the end product meet the requirements? And if there's a requirement that wasn't implemented, then that's going to be a big issue. From my perspective, that was what I like about having this ability is I can establish the model and the model will tell me when things are broken. And then I can do a report. Cary mentioned you get a report that says, show me all of my requirements that have not been implemented by code. And that would be a really exciting metric to see in a dashboard or something and manage my project.
Next question.
Someone asked about subscriptions and academic versions. It just depends on the school, I think. I think we have some relationships with a couple of institutions. Jared, do you have any academic licensing?
Not at the moment. We don't, no.
Yeah, and I'd say in general, we don't have a free academic license. We do have some paid university customers, but.
Okay, Cary, did you want to address my question?
From the perspective of convincing management for the need to get a tool that enables the organization to establish live traceability is aided by showing them the improvement development outcomes as it relates to return on investment. Have you made this correlation? Kevin, you want to chase that one?
Yeah, sure. So I think there's two elements to this. I think first off, from the ROI perspective, the traceability diagnostic that Cary pointed out, that was really sort of the intention of that, is helping prospective clients be able to measure out the values of our requirements management tool, just in the positive impact that it'll have in terms of remediating defects and improving cycle times. In terms of the traceability score and correlating that sort of to intra-company ROI improvement, I'd say that's sort of our next step. We're engaging deeply with some of our customers who have the volume of projects to look at ones that had good traceability and ones that had bad, and really sort of prove out that that traceability matters even at their individual level, and really do a deep dive for the specific reasons why. Were there specific gates that were impacted by a lack of traceability, or are there specific improvements we can identify from doing so? Second, I'd say what we really want to do is sort of enable live traceability in an active project and sort of go through that live feedback and making sure that the validation is there, that it's useful, and that the improvements in ROI by measuring traceability live time are there. So I'd say both yes and even more yes in the future.
Thank you.
Definitely.
Okay, Lewis had a comment.
Lewis says he created a relationship rule diagram for new projects since he has a team adopting Jama. And he would love to show it and talk about it and how they might relate to the traceability score. You want to share your screen, Louis?
Yes. So this, is not as clean and straightforward as your guys's, I guess, to a point. But there's a lot of relationships I wanted to track within Jama. Beyond going through, the ConOps, going to the system requirements, and then going to the subsystems. So a couple of things I wanted to ask about is, in terms of tracking my interfaces, I'm going to have an interface document that has like the interface definitions, and then each side of the interface is interface requirement that's within a subsystem. So, I have different sets of subsystem requirements for the different subsystems, and I want them to at least relate to each other. They don't define each other. It's just related. So I show that traceability between that as they both also relate to the interface itself. So I have that relationship. And then I have additional relationships. And I know the dotted lines are in there, so I don't have to worry about the coverage. It's not going to yell at me if things aren't covered because these are kind of optional. Like I'm tracking my TBXs that I have relationships with all applicable items and risks also that, may or may not be related to everything. And I think I'm probably an interface at some point turn these into, non-coverage items. So Jama doesn't yell at me for not having coverage. But yeah, so this is kind of like what I had going on. And I was just wondering, especially really of the subsystem requirement kind of relating to other subsystem requirements, like how would that kind of work with like a traceability score? With like maybe interfaces, maybe optional relationships that you don't always have?
That's a great question. So by default, we do include all relationship types in our score that are being used. So if it's optional, it will be included. But just as an example, let's say you thought you were going to have your subsystem requirements related to your interfaces, but then decided not to really do that, then we would not include the score, which is also helpful if you're mid-project and you haven't started implementing a certain relationship type yet. That being said, though, in terms of cases where they are truly optional, I think it's the process we see is you make the determination up front that that's not going to have 100% coverage. And then you can manage to that, right? And so then you can focus on the ones that do. And I think an end product of that is that does mean the traceability score would not be 100% if you do include that relationship. But operationally, that's fine. I think the project level traceability is really sort of a guiding North Star to measuring how traceability is improving over time. But it's really at the relationship level that it becomes operational and that you can differentiate between full traceability where it's needed versus situations where it's a nice to have. Does that make sense? Is that helpful?
Yeah, no, it's extremely. And so kind of a side question to this, though, how I have these traceability set up, how it kind of evolved over we had everything and I'm wanting to track pretty much everything in Jama. Is it expected for the relationship rule diagrams to start looking like a spaghetti monster, or am I just going overboard at some point?
It's definitely not a spaghetti monster. I mean, I have seen relationship models that probably have 3 times the number or more of objects in the web. Yours is actually pretty clean, very common. It's following some best practices that I've seen out there. I think you're on a really good track. The only one that I would highlight, it's one that you pointed out, was the subsystem to subsystem relationship. Sometimes I would argue that that's not necessary, or you should use a different item type to represent that.
Okay, terrific. Thank you.
Yeah, you're welcome.
I really enjoyed seeing this, the demo, especially from an interface standpoint, because interfaces is such a problem for a lot of organizations. Even though when you look at your requirement set, there's going to be just a percentage of the requirements that actually interface requirements. For those that are interface requirements, then you have distinct traceability rules that you want to enforce for that subset. Even though it's not enforced for all the requirements, you'd want it enforced for that subset. Interfaces take 2 players at least. And so if one element says this is an interface requirement, but it doesn't link to the other half, the other system that it's interacting with, that would be a defect. If neither one of them link to a common definition, that would be what we call a defect, which is a little bit different use of defect than what you're talking about. But it would be a break in the traceability because those relationships have not been established. So I'm really excited to see that as a way to be able to manage the interface requirements within the tool like that. That was great to see that in Lewis's demonstration.
And Lou, I was going to say, I took that idea from one of your white papers about interfaces.
Yeah, it looked like the relationship model for interfaces I have in the needs and requirements manual.
Yeah, exactly.
Raphael had a couple of questions. Are you able to define derived and refined and satisfied? It kind of be adjusted. In Jama, when you're creating a trace data model, you can choose whatever you want for these relationship names to be called. We have out of the box ones that use sort of SysML best practices, but you can have them called whatever you like. Raphael also asked to expand on examples for risk. This chart has a single object representing a risk that might be related to a requirement. This is very simple, but you could have risks broken out into multiple object types to keep track of it. Maybe you have a failure, maybe you have a hazard, maybe you have different elements that are different from each other that all form the domain of risk. So you could break those out into multiple items or have a single item and have it related to any part of the data model or multiple parts of the data model as well.
Cary, a question on risk.
Mm-hmm.
Just like we talked about, verification could be maybe a different tool. The verification is managed in a different tool maybe, but then through traceability, you can link the requirement in Jama Connect to that other tool that's managing the verification activities. So could the same be true for risk? I have a tool that focuses on risk, but then the risks are going to be mitigated by a requirement, then I could establish that traceability.
Yep. We have plenty of people that are using Excel as a spreadsheet to manage risk, and then they tie their spreadsheets to requirements so that they can, see the risks in Jama so that you can make the correct traces so you could understand, where you've mitigated your risk through requirements. Then the same as with LDRA on the testing side. You can see that full breadth of the traceability of requirements in LDRA itself and in their tools, and have the information flow back into Jama.
So if I'm a regulator, to me, that's really important because I could be managing my risk identification and just risk management in one place. And then for those that are going to be implemented by requirement, then I can trace to that in Jama Connect. But then that requirement's being implemented in code, and I can use the other application and have a link there. And then the verification that the systems actually met that requirement, then I can do that. So now I've went across about 4 different tools, but from a regulator standpoint, I've got a positive trace all the way through that particular risk was mitigated. And I verified it was mitigated.
That's sort of the goal of the Traceability Alliance, is to have that alignment on how traceability is used by our customers, by you. We'll get another question. Let's see. Oh gosh, Gary asked a question: what do risks look like with the ISO 14971 templates? I don't have a running system of Jama that has that, but we have templates for ISO 14971, and it has all of the risk, a set of attributes to track those risks and to mitigate those risks and do the calculations. We can point you to that for material.
Yeah, thanks. I was just wondering if that was done in a standard way as well across the industry.
14971 doesn't describe a specific template per se for how to track risk management. It prescribes a process, but it doesn't say thou shalt use this exact template. It has a higher level one. We have a generic template that matches the generic template within 14971 that is then tailorable by our customer. I hope that made sense.
Yep, that does. Thank you.
You're welcome.
So Cary, a question on the Alliance. If a tool vendor wants to join that Alliance, how do they do that?
I guess just reach out to us. We've already started to talk with some other organizations that are interested in joining. So you can reach out to myself. I partner with all of the vendors in the Alliance, and we can bring you on board.
So the ability to link data within different tools is not really the same as being able to share data between tools. Those are 2 different topics. Is that right?
They are kind of two different topics, but they are interrelated for sure. Unless your data model allows for sharing, it might be hard to do that traceability, right? So there are ways to use standards to have data models that are compatible, though.
Okay, does anyone else have any questions?
I have one question, Francesco here. Thank you very much for this nice talk. Can you kindly go back to the slide about defining the trace data model, please? My question is, I know that Jama has been put on the market as a requirement management tool, but when, for instance, I see this kind of a model, it seems to me that actually is becoming a data-centric tool, or probably also a systems engineering model-based tool, because clearly it's a nice way to connect different systems engineering processes in a systematic and systemic manner. Is that a strategic change, which, by the way, I like very much, also because I noticed that you are also trying to implement really specific engineering disciplines like RAM. The way it was like, I noticed MECA and this kind of thing. So really a tool that is connecting many disciplines.
We do consider ourselves a systems engineering tool. If you were to ask us, hey, can you use our tool for MBSE? We would say yes. We try to have, just as you said, a data-centric focus to our MBSE. We're not a SysML tool. We're not a graphical modeling tool. We don't even try to pretend that we are. We are, however, a great MBSE tool for an organization that doesn't need the complexity of SysML, but still wants to take advantage of being able to have data that's consistent, that you want to constrain users to create good data to be able to measure and to be able to then query across the data from many different angles and do that type of analysis. So yeah, we're definitely boldly calling ourselves an MBSE tool. And through our Traceability Alliance, we integrate with tools that are SysML tools as well. So that's why we actually call ourselves a companion MBSE tool. And this particular data model that's shown on the screen is the data model for our companion MBSE template.
Thank you very much.
You're welcome.
Cary, could you explain a little bit more what you mean by companion?
It's not a separate thing. It's more like just like an adjective. I chose the word companion to kind of set itself apart in the market so that people understand that, hey, you can use Jama Connect as a companion to your SysML efforts. Most of the customers that I have talked to or users of a SysML tool are still describing the need to use a tool for requirements management, to use a tool that can keep track of verifications and validations and that traceability. That the system modeling tool isn't enough. It's really only designed for the system model. And then so you can use Jama as a companion to the system model. And Jama covers the front end of the life cycle that needs all of that mission needs and goals part, as well as connecting to the implementation end. So if you're all the way down inside of code or into automated testing, Jama then becomes the place where you look at and analyze the traceability for all that. So that's why we call ourselves a companion MBSE.
That makes a lot of sense. Organizations, due to the complexity, they need a tool set.
Yeah.
And the tool set needs to be able to play nice together. And through the Traceability Alliance, that's one thing you're helping to do that. So I noticed that our time has went by us very quick.
Hey, Lou, I got one quick question.
Okay.
I was wondering about integrated data as a foundation for SE. How does this fit in with that, with your vision of that?
Gary's talking about a white paper the requirement working group put out several years ago called Integrated Data as a Foundation System Engineering. Its real premise is that the real intent of MBSE is the data-centric practice. And so we're forming a data and information model of our system as well as the system engineering artifacts. And then no matter what tool you're using, it's just a different visualization of that integrated set of data. We put that out several years ago when MBSE first came out. And to me, this whole thing that Cary's talked about is the ability to link things across the life cycle, even to develop different tools, very much meets the intent of what's in that white paper.
Thanks, Luke. That makes sense to me too.
Also, I want to point out, if you go to the NCOSE RWG YouTube channel for IW 2022, Cary put on a panel with several different tool vendors, and they discussed that integrated data philosophy a little bit and what the state of the art was at the time. And there may be some stuff in that presentation that you may find useful also, Gary.
Sounds good. Thanks.
So with that, I think it's time to depart. I want to thank Cary and Jama Connect in general for supporting the Requirement Working Group the way you do. The working group really wants to further the practice of system engineering through needs and requirements and traceability across the life cycle, knock down the silos. And Jama Connect is definitely, a tool that's supporting our goals. So I'm really excited to see various tool vendors that are realizing that vision. So thank you, Cary.
Thanks so much for the opportunity to collaborate with the Requirements Working Group.
You're quite welcome. So with that, Louis, I think you can stop the recording.